Good day to everyone. Today we will be discussing Module 3, which is all about the Rankine's active and passive earth pressure with sloping backfill. First, we will be dealing with the active pressure, and then later on to be followed by the passive pressure. So Rankine's active pressure with sloping backfill, and the soil is said to be cohesionless, since we will be considering when soil has a cohesion of 0. Or in short, the backfill is simply cohesionless. In some cases, the backfill may be continuously sloping at an angle alpha with the horizontal. So this is our backfill, and this time it is sloping, so it makes an angle of alpha with the horizontal. So note that in our previous discussions, Module 1 and Module 2, the backfill is purely horizontal. In such cases, the direction of the Rankine's active or the passive pressure are no longer horizontal. Rather, they are inclined at an angle alpha with the horizontal. So notice that when we plot the pressure diagram from our previous discussion, the active or the passive force is always acting horizontally. So this is what changes in a sloping backfill. So this time, the direction of the Rankine's active or the passive pressures are no longer horizontal. Rather, they are inclined at an angle alpha with the horizontal. So just like here, this is now the diagram of our active force, piece of A. So it's not acting horizontally, but it acts on an angle same as the angle of the sloping backfill. So if the backfill is a granular soil with a drained friction angle, and C prime is equal to 0 or cohesion is equal to 0. So again, as you can see, the cohesion here is highlighted because we are dealing with cohesionless soil. Then the active earth pressure is equal to the unit weight multiplied by the depth multiplied by the coefficient of active earth pressure. So this is also the equation that we had been using from our previous discussion. So what has been changed is on how are we going to solve for the value of this coefficient. Again, note that this is the equation we had been using if soil is cohesionless, and the case of A is the Rankine's active pressure coefficient. And in this particular situation, in a sloping backfill, the case of A is solved through this equation, that is cosine alpha multiplied by cosine alpha minus the square root of cosine squared alpha minus cosine squared multiplied by the angle of friction divided by cosine alpha plus the square root of cosine squared alpha minus cosine squared angle of friction. So alpha is the angle that the sloping backfill makes with the horizontal, and then of course this phi is your angle of friction. So the active force per unit length of the wall can be given as piece of A, active force is equal to 1/2 multiplied by the coefficient multiplied by the unit weight multiplied by h squared, or the height squared. So the line of action of the resultant acts at a distance of h all over 3 measured from the bottom of the wall. So it is always h all over 3 measured from the bottom of the wall. The following table gives the values of the coefficient of active earth pressure for various combinations of angle alpha and the angle of friction. So other than the equation, we can also get the value of case of A using this table. So if we have a specific angle of friction and alpha angle, we can determine the value of case of A using this table. But kung wala dito yung values natin ng alpha and the angle of friction, then we will be using the equation. So this time, we now consider passive pressure, still with sloping backfill. So in a similar manner, the Rankine passive earth pressure for a wall of height h with a granular sloping backfill can be represented by the equation. So same equation as we had in the active. It's just that we have to change, of course, the subscript to designate that we are dealing or we are talking with the passive pressure this time. So case of P is the Rankine's passive pressure coefficient. And the case of P is computed through this equation. So this is the same as what we had used in the active. What has been changed is this sign. So in the active pressure, this is minus and this is plus. And the same also in the computation of the passive force, that is simply 1/2 multiplied by the coefficient of the passive earth pressure multiplied by the unit weight of the soil and multiplied by the height squared. So the resultant of the force is inclined at an angle with the horizontal and intersects the wall at a distance of h/3 measured from the bottom of the wall. So as usual, the resultant is acting h/3 measured from the bottom of the wall. This table, table 13.3, gives the values of coefficient for passive earth pressure for various combinations of alpha and angle of friction. So whenever you are using the table, see to it na you have to read the title because there are dedicated table for the active earth pressure. There is also a dedicated table for the passive earth pressure. So same, if we have here a specific alpha angle and the angle of friction, we can get the value of case of P using this table. But if the value of the alpha and the angle of friction is not here, then still no problem because we can still use the equation that was presented a while back. Let us now consider a sample problem. A wall of 8-meter height retains sand having a unit weight of 19 kilonewton per cubic meter and an angle of internal friction of 34 degrees. If the surface of the backfill slopes upwards at 15 degrees to the horizontal, find the active thrust per unit length of the wall. So use Rankine's condition. So first we have to identify the given. H is given to be 8 meters. Unit weight of the soil is 19 kilonewton per cubic meter. The angle of friction is 34 degrees. And the alpha is 15 degrees. So what is required? That is the active force per unit length acting on the wall of 8 meters. Alright, so we have here an illustration. We have here your 8 meters wall. And then we have here your backfill. And the properties of the soil is the unit weight is 19 kilonewton per cubic meter. And the angle of friction is equal to 34 degrees. Also, alpha is given. So alpha again is the angle that the slope makes with the horizontal. So this is given to be 15 degrees. So we are to solve for the active force unit. So using the equation, piece of A is equal to 1/2 multiplied by the coefficient of active earth pressure multiplied by the unit weight multiplied by the height, we can analyze from the equation that the height is given, unit weight is given. So all we need to know is the value of the coefficient of active earth pressure. So we can determine this using the following equation. So case of A is equal to the cosine alpha. So again, the alpha is given, that is the angle that the slope makes with the horizontal. And then another parameter in the equation is the angle of friction, which is also given. So from here, we can directly substitute this equation, and that becomes cosine of 15 degrees multiplied by the quantity cosine 15 degrees minus the square root of cosine squared 15 degrees minus cosine squared 34 degrees divided by cosine 15 degrees plus the square root of cosine squared 15 degrees minus cosine squared 34 degrees. So be careful that you do not interchange the values. Be careful that you substitute the values correctly. So this equation will now yield a value of 0.311. Again, this is a coefficient, so it is unitless. Let us also try to use the table to identify the values of case of A. So again, the angle alpha is given to be 15 degrees and the angle of friction is given to be 34 degrees. So from the table, we have here the angle alpha. So you have here the arrow down, which means that we will be, for the alpha angle, we'll be considering these values, not these values. So this values is for the angle of friction. So you have here also the arrow going to the right, so this will guide us. So the alpha is this one, and the angle of friction is these values. So going back, our alpha is given to be 15 degrees, and upon checking, we have here 15 degrees. And then next is the angle of friction is 34. So we have here 28, 30, 32, and 34. So let us also project that. And then where the two intersects together, this is now the value of active earth pressure or case of A. So notice that it's 0.311. It was the same value that we computed from using the equation. Alright, so if again, if the values for the alpha angle and the angle of friction is available here, we can simply use this table. But if it is not available here, then let us use the equation. So if both are available, you can choose whichever method are you going to use. So since we already know the value of coefficient, we can now substitute piece of A is equal to 1/2 multiplied by coefficient multiplied by the unit weight multiplied by the height squared for us to determine the value of the active force. So that is 1/2 times coefficient is 0.311 times the unit weight is given to be 19, and then the height is 8 meters. So this now will yield to a value of 189.088 cubic meter, and meter squared will cancel out, so we are left with kilonewton per meter. This is now our answer.